ISEK is the International Society for Electrophysiology and Kinesiology. So it was a lot of basically neurology and neuroscience nerds, basically. So there was quite a few people that do a lot of motor unit research, kind of similar to what we do. That presentation that I had was off of a project that we did starting my first semester here. Where basically we just did resistance training of like a small muscle in the hand, just the FDI, which is just that muscle right here. So it was a lot of finger wagging, basically just doing this back and forth. So basically with that, what we saw was basically like a different version of a previous presentation that I had. Basically looking at changes within like a submaximal contraction pre and post that resistance training intervention. Basically what we saw is that there was no like significant differences, but the thing that we were able to kind of dig into with that, especially like all the figures and actually like plotting out the way the data actually looks, is that there is a tremendous amount of variability in with that. I plotted basically like a 95% confidence band, and there's just a whole bunch of overlap everywhere. So basically meaning if you're able to find a way to get that tightened up a little bit, there may actually be something that we can see there, depending on, is it, poor contraction quality, poor skin prep, something like that, or do we just do our analysis wrong? That's also a possibility. But basically what we saw is that at 50% of whatever your NBC is pre and post training, the way your brain organizes how it conducts that movement does not change from pre to post, or if it does not change uniformly across the population that we looked at. I think it kind of just reinforces the point that, especially when it comes to like just the human body in general, but especially like the nervous system, it's super complicated. There's a lot of detail there that you have to account for. And the brain is very good at doing what it already does, especially for a muscle like the hand, which there's some advantages and disadvantages to looking at that. One is kind of like a double-edged sword almost, is that we don't use the hand for like loading really much. You don't go in the weight room and see people like banging out sets of this on the cable machine at all, which makes it very appealing to look at for like purely novel resistance training intervention. But on the other hand, we don't do that type of task at all. So one, how practical is something like that compared to like something like the quads, where we do care about or do load it a lot more. But also like we don't really need to exert a lot of force to the fingers in our daily life anyways, at least for most people. So why would the brain like change what it does for that? And just in response to just like a quick 2 weeks of lifting some weights with your hand. And it was a really small, it wasn't really like a hard training study for people to do either. So they did get a whole bunch stronger, but that might be purely more like something's going on within the muscle. We did see that their muscle size did increase a whole bunch within that really short time frame. So that might be something that kind of challenges some of the hypertrophy research a little bit. I don't think it's really like contradicting anything. I'm just thinking it's more along the lines that if you have a muscle that just does not get loaded in that manner at all, really, it has a really sudden and it's very easy to create a hypertrophic response in that muscle versus a muscle that we do tend to load a little bit more, even if you're not really trained. For example, someone who doesn't lift weights but starts doing a bunch of leg strength training, their quads aren't going to look huge like those sprint cyclists or anything like that. Whereas the hand, we still aren't loading them, but versus the quad, you still walk up and down the stairs, you still pick things up off the ground, you walk the dog, carry groceries, do other things like that. So that might be part of the reason why we weren't really able to see anything like that. So really it kind of gets me thinking if there are neural changes that are happening, they're probably somewhere else along the pipeline compared to just firing rates against motor unit, actual potential amplitude, or recruitment threshold, which is what we tend to go for immediately when we look at.